so I don't forget. All right, ready? Here we go. All right, so today we're going to go ahead and apply the beautiful angle addition postulate. Very similar to the segment addition postulate. Yeah, a little bit different because we're dealing with another figure now. We're dealing with angles. So we're going to see some relationships. Yes, we're going to go ahead and see some, again, no relationships. But again, we're going to go ahead and apply the angles that were given. And we're going to go ahead and find what the greater angle is. Now, everybody has this, right? Ready? Okay. So yesterday we went over all about, not yesterday, the day before that. We went all about angles. We told you guys that this is a ray, this is another ray, and it had a common endpoint called the vertex at B, and then therefore we had a measurement now of what we call degrees, right? We went over the definition, our beautiful example, and then our classification, and then we went to measuring beautiful angles. All right. After we measured, we were able to identify which ones were acute or obtuse or right angles. Now, here in this case today, we're going to go ahead and add a little more to our angle in this case. Now, our angle can have more rays added to that same endpoint or to that same vertex, depending on where the point is located. Now, we can go ahead and have our beautiful point, let's say S. Here, pointed here in the center, and we have now two angles. We can have that beautiful point here. Let's go ahead and say T, and we have another angle. We have another point, let's say U, over here, and we can make another beautiful angle. And we can go ahead and do this infinity many times until we have beautiful angles. But at the end, it's going to add up all together. We're going to add the value of all these angles together, and we're going to have that larger, beautiful angle in this case. So that's what it basically tells us. We're going to go ahead and have all those angles together. So where is this seen in real life? You guys have ever held a hand fan? Yeah, when it gets hot here in the summer? You're like at church, or I don't know where else, like at a graduation, especially. You're like trying to cool yourself down. Notice here that all the little parts or the little I'm gonna say wooden pieces or wooden spokes of your beautiful fan all join at the same vertex point right here. So whenever you're able to open it, you have many angles joined together at one vertex. The same thing happens here in a book. So whenever you guys open your book, whenever the pages flip and they just fly in the middle, since they're all connected at the spine of your beautiful book, then you have, again, many angles joined at one particular vertex here, which is considered your spine right there. All right, so that brings us up to our beautiful angle addition postulate. This one's a basic one. It's basically telling us if we have a point S and it exists in the interior of a beautiful angle, so PQR, so P, Q, and R, then we can go ahead and construct a ray that goes from Q to that point S, and then have our beautiful addition postulate, which is now the measurement of angle PQS plus the measurement of angle SQR, and it's now equal to the entire angle. Measurement of PQR. Copy this in your notes, please. Something that is new to you guys today is this little symbol. I hope you guys were able to identify it. This one right here. You're probably asking yourselves, Ms. Vasquez, what does that mean? What is that measurement? Or what does that M mean before my angle symbol? Whenever it's present, you're talking or you're describing the measurement of that beautiful figure. So it can be used for segments. So for example, measurement of your beautiful segment AB. You can use it for angles, or you can use it for lines as well. So whatever you guys decide to use it for, or in this case, it's placed in front of your angle, which means we're going to be talking about its measurements, okay? Now, in this case, PQS is right here. P, Q, and S. SQR is right here. S, Q, and R. And whenever we add those two beautiful angles together, it's going to give you guys the measurement of the entire angle, which is from P to Q to R. So from P to Q to beautiful R. So we're going to go ahead and have a series of angles that add together. In total, it's going to equal to the larger angle. Okay. All right. Let's go ahead and clear. Ready for our first example? Here we go. Go ahead and copy this one down using the angle addition postulate. Measurement of angle ABD is 37 degrees. The measurement of angle ABC is 84. We're going to go ahead and find the measurement of DBC. I'll let you guys copy this down. Okay, let's go ahead and start solving it first. Before we solve it, like I say, always write your postulate first. Identify what it's saying first, then you can go ahead and substitute your values and then solve. Some of you guys can just look at it and then solve it mentally. Yes, I understand, but it's going to start getting more complicated today. So I'm going to go ahead and ask you guys to write your angle addition postulate first. So let's go ahead and start with our beautiful angles. What is our first angle here? ADB. So measurement of angle A, B, D. That one's being added to what angle? DBC. So let me go ahead and highlight this one. Measurement of angle DBC. This one right here. And this one is angle ABD. And in total, it should equal, whenever I add those two together, what angle? ABC. So I'm going to go ahead and make sure that I have it as a result. ABC, measurement of angle ABC. Perfect. My entire beautiful angle. Now, let's go ahead and start putting values to it. What information am I given? What's my first information? ABD, and this one is 37 degrees. Okay, let's go next. Are we given DBC? No, we have that missing, so I'm going to go ahead and leave it as measurement of angle D, B, and C. And it's equal to, are we given ABC? Yes, let's go ahead and substitute that value. It is 84 degrees. Okay, perfect. Now, our segment addition postulate says that we have 37 degrees added on to that beautiful measurement of angle DBC, and in total, it gives me a result of 84 degrees. How do I solve for that? What would I do? Saying that 84 degrees is what measures the entire angle. This little piece that we have here is present, 37 degrees. And it's asking us to find this missing information. How would we find it? We're going to go ahead and do inverse operation. So we're going to have to subtract 37 on both sides. So let me go ahead and grab my tool. Subtract 37 degrees on one side. Subtract 37 degrees on the opposite side. This goes to 0. And we're left with measurement of our beautiful angle DBC equals, what is 84 minus 37? What is it? 47, that is correct. 47 degrees. So we now are able to find the measurement of this beautiful angle. Not too bad, huh? I see you questioning. You're sleeping? Okay. All right. I think it's just something going around. Either we're just tired. We need a little break. I don't know. Do we need a brain break? Some of you guys, yes. Okay. I'm going to make you guys do a rock, paper, scissors or something. So you can have a brain break after this. Okay. Number 2. Go ahead and copy this one down. We have measurement of angle XWZ equals 121. The measurement of XWY equals 59 degrees. And the measurement of our beautiful angle YWZ we need to find. Okay. I'm going to be randomly asking you guys to tell me what do we have? What do we have missing? How do we write our beautiful angle addition postulate? And how do we solve? Now that we know how to apply the segment, the angle addition postulate, in this case, we have the measurement of what information is given. Who went last? Cadence. No, it was Cassandra. Cassandra, pass it on. Brennan. So what information is given? Which are? X, Y, Z. So let's see, X, Y, and Z. That's my entire beautiful angle. That's equal to 121. Now, if it's the entire angle, whenever we write our beautiful angle addition postulate, that information will be written on the right side. So let's go ahead and write that out. So measurement of our beautiful angle, XWZ. Perfect. Brian, pass it out. Diego, what other information do we have? XWY. So let's go ahead and identify X, W, and beautiful Y. This beautiful angle right here, and this one states that it measures 59 degrees. Don't forget your symbol. My pen is not working. That's why I'm like writing super, super slow. So that one is going to be added on to what angle? Pass it on, Diego. So what angle do we add to XWY? To apply the segment, the angle addition postulate. There you go, the last angle that's left, which is YWC. So measurement of angle YWZ. Perfect. Now let's go ahead and substitute our values. What do we have here? We have XWY, which is 59 degrees. Measurement of YWZ is missing. Measurement of YWZ. And then equals our beautiful measurement of XWZ, which is 121. Go ahead, Mio. All right, what do we do here? Subtract what? 59 on both sides. Let me do it in blue. Minus 59 on both sides. Minus 59 on both sides, and we're left with measurement of our beautiful angle that we're looking for. YWZ equals 62, 63. Notice here it's 9. To get to 11, it's 2. So 62 degrees in this case. Raise your hand if you got that. All right, sure. Okay, now ready to step it up, guys? Not yet. Do you guys want another one to practice on your own? You guys are good? Okay, from a scale from 1 to 5. 5 being that I'm ready to move on, Ms. Vasquez. 1 being that I still need some extra time or extra steps. 5 being that you're good to go. 3-ish, 2, okay. So I see 5s, okay. Majority are 5s. I'm not gonna make you guys do the last one. So this one's your turn. Okay, let's go ahead and go on to the next one. This one's a fun one. Number 4. I told you guys, are you ready? Do you guys want to go back to 3 now? Okay, so now it's gonna get more fun, guys. We're gonna instead of have actual degree values, we're gonna have expressions included. That's the fun part. Now we're gonna go ahead and identify what we're given so that we can go ahead and create that angle addition postulate and then substitute the values to it. Now it is important to do that so that we can go ahead and identify everything, make sure we're substituting correctly. We know what equals to what adds to what. Okay. Now, Go ahead and tell your neighbor, how do you write the angle addition postulate to this beautiful figure? Go ahead and tell your neighbor. Okay, who went last? Jorge, yes, you did. Pass it on. Marie, so how do I write my angle addition postulate? I'm not going to use any colors here. I'm going to go ahead and just keep it all black. So what are my angles here? It's HGF. HGF is what? My entire angle or the pieces? The entire angle. So that's written on the right side, right? So measurement of angle HGF. Now, what angles compose HGF? EGF. So measurement of angle E, G, and F. What other angle does it include? HGE. So measurement of angle H. G. There you go. Perfect. All right. So I'm going to go ahead and highlight them so you guys can see it. This right here. It's right here. This angle right here. EGF is right here. And the last one, my entire angle is right here. Okay. Not too bad, huh? No? Okay. Now, what information am I given? Marie, pass it on. Ivana, what information am I given? We're not solving yet. We're just substituting now. EGF information is given. So let's go ahead and substitute that. EGF is what? 110. So 110. EGF 110. Pass it on, Ivana. Brenda, what other information do we have? HGE, which is what? There you go, 3x plus beautiful 11. And you know this, Brenda, what's the other information that we're given? HGE, which is 16x plus 6. Do I have it mixed up yet? Yeah. Okay, let me go ahead and fix it, guys. I was writing it down. I was like, wait, that was the outside one. Oh, wait. Just the expressions were mixed up. Okay. There you go. 3x plus 11. 16x plus beautiful 4. Okay. Thank you, guys. Brenda, pass it on. Yes, what's the rent? Take the 5. Danny, okay. So what is my next step? Now that I substitute all my values, I constructed or wrote down my angle addition postulate. What do I do next? So we simplify, so we're going to go ahead and combine like terms. What terms are alike? So 110 and beautiful 11. So let's go ahead and combine those two together. We have 3x plus 110 plus 11, guys. 121 equals 16x plus beautiful 4. Pass it on, Denny. Dennis, what is my next step? We have a multi-step equation now. So let's see, what's our first step? Now we can start the inverse. operation. Inverse. So how do we solve for inverse now, guys? What's our next step? Subtract. Let's do the variables first. 3x. Okay, so let's go ahead and eliminate 3x first. This goes to 0. We're left with 121 equals, what is 16x minus 3x? 13x plus 4. What do we do next, Jen? What do we do next? It's a 2-step now. Back to you. Oh,
Back to me?
yeah. So if you were to solve for this equation right here, 121 equals 13x plus 4. It's a 2-step now. Subtract what? 4 on both sides. So there you go. So subtract 4. Subtract 4. We're now left with, what is 121 minus 4? 117 equals beautiful 13x. And my last step, divide by, I don't have enough space, but let me go ahead and write it over here. 117 equals beautiful 13x. Divide by 13. I ran out of space down there, guys. And we're left with x equals beautiful 9. Is that all it's asking? Yes, it's only asking to find the value of x. Now, if we were to ask for one of the values of the other angles, we can go back and substitute. Okay, any questions on this, guys? No. Okay, so I'm gonna go ahead and give you guys the homework so you guys can work on it for the rest of the class period. And you guys don't worry about anything else. It's numbers 1 through 8, guys, but I changed it from numbers 1 through 6. Numbers 1 through 6. The last two, I didn't go over angle bisectors yet, so I'm gonna go ahead and do that tomorrow.